Hello there, and welcome to The Sleepy Scientist. Tonight we're going to take a slow and gentle journey through the universe, exploring one simple but surprisingly mysterious question. Why is the night sky dark? So get comfortable, relax your mind, and let the quiet story of the cosmos unfold. And if you enjoy calm explorations of space and science like this, consider subscribing to the channel and joining us for more peaceful journeys through the universe. Let's begin. Have you ever stepped outside late at night, looked up at the sky, and wondered about the quiet darkness above you? Not just the stars, but the darkness between them. On a clear night, far away from city lights, the sky can feel almost endless. Thousands of stars scattered across the darkness, tiny points of light shining across unimaginable distances. And yet, despite the vast number of stars in the universe, the sky is mostly dark. This simple question has puzzled scientists, philosophers, and curious minds for centuries. Because when you really stop and think about it, the darkness of the night sky is actually very strange. Consider this for a moment. Our galaxy alone contains hundreds of billions of stars, and beyond our galaxy there are billions of other galaxies, each one filled with their own countless stars. If the universe is so full of stars, shining in every direction, then why doesn't the entire sky glow with light? Why doesn't the night sky blaze with brightness, instead of resting quietly in darkness? It seems like a simple observation, something we've all accepted since childhood. Daytime is bright, nighttime is dark. But when scientists began thinking deeply about the universe, this ordinary fact became a profound mystery. A mystery so puzzling that it became one of the most famous questions in all of astronomy. To understand this mystery, let's begin with a gentle thought experiment. Imagine standing in the middle of a very large forest. The trees stretch out around you, in every direction. Everywhere you look, there are tree trunks, leaves, branches, layer after layer fading into the distance. Now imagine that the forest is infinite. It never ends. No matter how far you walk, there are always more trees ahead of you. In such a forest, if you looked in any direction, eventually your line of sight would always land on a tree. There would be no empty spaces. Your view would be completely filled with trees. Now let's replace the trees with stars. Imagine the universe is infinite, stretching forever in all directions. And imagine that stars are spread throughout this infinite space. If that were true, then every direction you looked in the sky, your line of sight should eventually reach the surface of a star. Not immediately, perhaps after millions, billions, or even trillions of kilometers. But eventually, somewhere along that line, there should be a star, which means the entire sky should be glowing. Not dark, not quiet, but bright, almost like the surface of the sun. Yet, when we look up at the night sky, we see something very different. We see darkness, vast oceans of darkness, with tiny islands of light. This puzzle became known as one of the great cosmic questions. Why is the night sky dark? For centuries, many people simply assumed the answer must be obvious. Perhaps there aren't that many stars. Perhaps the universe isn't that big. But as telescopes improved and astronomers began studying the heavens more carefully, they discovered something astonishing. The universe is far larger and far richer in stars than anyone had ever imagined. Our own galaxy, the Milky Way, is a swirling island of stars over 100,000 light-years across. Inside it, there may be between 100 billion and 400 billion stars. Our Sun, the star that warms our planet every day this Laura, is just one of them. And our galaxy is not alone. When powerful telescopes began peering deeper into space, astronomers discovered that the universe is filled with galaxies. Thousands of them. Millions. Billions. Each one containing billions of stars. In fact, when scientists point modern telescopes at a tiny patch of empty sky, a region that appears completely dark to our eyes, something incredible happens. The darkness slowly fills with light. As the telescope collects faint photons from distant space, hidden galaxies begin to appear. At first, a few faint smudges, then more, then hundreds, then thousands, all packed into a region of sky so small it could be covered by a grain of sand held at arm's length. Every one of those smudges is an entire galaxy, containing billions of stars. And when scientists realized this, the mystery of the dark night sky became even deeper. Because now the universe didn't look empty at all. It looked crowded, overflowing with stars. So once again, the question returned. If the universe is so full of stars, why is the night sky still dark? To begin answering that question, we have to travel into one of the most fascinating ideas in astronomy, an idea known as Olbers Paradox. The paradox is named after Heinrich Olbers, a German astronomer who thought deeply about this problem in the early 1800s. But the question itself is even older. Astronomers had been wondering about the darkness of the night sky for generations. Olbers simply helped frame the puzzle in a clear and powerful way. If the universe is infinite, if it has existed forever, and if stars are scattered throughout space, then the night sky should be bright. Every direction we look should eventually end at the surface of a star, layer upon layer of distant stars, stacked across the depths of space. Even if many of those stars are incredibly far away, their combined light should fill the sky. Yet that is not what we see. Instead, we see darkness. A quiet, peaceful darkness that stretches between the stars. So something about our assumptions must be wrong. Either the universe is not infinite, or it has not existed forever, or the light from distant stars cannot reach us, or perhaps something even more surprising is happening. To unravel this mystery, scientists began rethinking what the universe really is. And slowly, piece by piece, a new picture of the cosmos began to emerge. A picture far more dynamic, far more mysterious, and far more beautiful than anyone had imagined. It began with a realization that seems simple, but changes everything. The universe has a history. There was a time, long ago, when the stars did not yet exist. A time when galaxies had not yet formed. A time when the universe itself was younger, smaller, and very different from the cosmos we see today. In other words, the universe has not been shining forever. The stars have only been lighting up the darkness for a limited amount of time. And that simple fact begins to explain the darkness of the night sky. Because light, even though it travels incredibly fast, still takes time to cross the vast distances of space. Light from the sun takes about 8 minutes to reach Earth. Light from the nearest star beyond our solar system, Proxima Centauri, takes more than 4 years to reach us. Light from the center of our galaxy takes around 26,000 years to arrive. And light from the most distant galaxies we can observe has been traveling for billions of years. This means that when we look out into the universe, we're also looking back in time. The farther away something is, the older the light we see. A galaxy 1 billion light years away is showing us what it looked like 1 billion years ago. A galaxy 10 billion light years away shows us a time when the universe was still very young. And beyond a certain distance, the light from stars simply has not had enough time to reach us yet. Imagine lighting candles across a vast dark field. If you light the closest candles first, their glow reaches you quickly. But candles farther away, their light takes longer to arrive. If the field is large enough, and if the candles were only lit recently, there will still be regions where the light hasn't arrived yet. The universe works in a similar way. The stars began shining billions of years ago, but the universe is so vast that much of their light is still traveling through space. Some of it will never reach us at all. So when we look into the night sky, we are not seeing an infinite universe filled with eternal light. We are seeing a universe with a beginning. A universe where stars turned on gradually over time, and a universe where light is still making its long journey across cosmic distances. But even this is not the whole story, because another extraordinary discovery changed our understanding of the cosmos even further. Scientists discovered that the universe is not just sitting still. it is expanding. Space itself, the fabric of the cosmos, is slowly stretching. Galaxies are drifting farther apart. Distances between cosmic structures are growing larger over time. And this expansion has a surprising effect on light. As light travels through expanding space and its wavelength stretches, the light becomes longer, redder, and weaker. This phenomenon is known as redshift. Light that began as bright visible light can be stretched into infrared, microwaves, or even longer wavelengths that human eyes cannot see. So some of the light from distant stars and galaxies hasn't disappeared. It has simply shifted beyond the range of visible light. The universe is still glowing, but much of that glow exists in forms of light invisible to our eyes. In fact, if our eyes could see microwave radiation, the entire sky would appear softly glowing, because surrounding us, filling every direction of space, is the faint afterglow of the early universe, a gentle cosmic whisper known as the cosmic microwave background. It is the oldest light in the universe, a relic from a time nearly 14 billion years ago, when the universe was still young and hot. But to our eyes, this ancient light is completely invisible, and so the night sky appears dark, quiet, peaceful. But hidden beneath that darkness, the universe is alive with light. Light from distant stars, light from faraway galaxies, light from the earliest moments of cosmic history. All of it travelling through space, crossing unimaginable distances, slowly weaving the story of the universe. And when we stand under the night sky, gazing upward into that darkness, we are not looking into emptiness. We are looking into time itself, a vast archive of cosmic history, written in faint rays of ancient light. And perhaps the darkness of the night sky is not a mystery after all. Perhaps it is simply a reminder that the universe is still unfolding, still expanding, still sending its light across the endless sea of space, and that somewhere, far beyond the stars we can see, countless more lights are still on their way, travelling silently through the cosmos, on a journey that began billions of years ago, and may one day finally reach our eyes. And as we continue to sit beneath the quiet night sky, it can be comforting to remember that the darkness above us is not empty at all. It only appears that way. Between the stars that shine brightly enough for our eyes to see, there are vast distances filled with faint light, ancient light, light so weak that it slips past our vision unnoticed. Photons from distant galaxies pass silently through space. Some of them have been travelling for billions of years. Imagine that for a moment. A tiny particle of light leaving a distant star long before Earth even existed, before our planet formed, before the dinosaurs walked across ancient landscapes, before the first forests grew on land. That small particle of light began its journey, across the quiet depths of space, drifting through darkness, never stopping, never slowing. And only now, after billions of years, it finally arrives. It reaches Earth. Perhaps it lands on the surface of a telescope, or passes quietly through our atmosphere. Maybe, just maybe, it touches the retina of someone gazing up at the stars. For a brief instant, a journey lasting billions of years ends in a single moment of sight, and then it is gone. The universe is full of these quiet travellers. Every star in the sky is sending out countless photons in every direction. Some of them spread outward forever, never encountering anything at all. Others eventually reach distant planets, drifting across alien skies. Some collide with dust grains floating between the stars. Some fall into black holes, disappearing beyond the point of return. And a few, a very small number, arrive here, on Earth. But because the universe is so vast, and because stars have only existed for a limited time, most of the sky remains dark. The darkness is simply the space between the lights, and those spaces are unimaginably large. To understand just how large, let's gently zoom outward from our small place in the universe. We begin here on Earth. Our planet circles the sun once every year, moving quietly through space at about 30 kilometers per second. It feels fast, but on cosmic scales, it is a very small motion. The Sun itself is just one star among many. It sits in a quiet region of our galaxy, about 26,000 light-years from the galactic centre. Around us, scattered through the Milky Way, are hundreds of billions of other stars. Some are larger than our Sun. Some are smaller. Some burn brightly for millions of years, while others shine gently for billions. And between them, enormous regions of space stretch out in darkness. The nearest star beyond the Sun is more than 4 light-years away. If we could travel at the speed of a jet airplane, it would take over 5 million years to get there. That distance, just to the nearest star, already hints at how empty space really is. Stars may appear crowded in the night sky, but that is an illusion created by distance. They are separated by enormous voids. Now, imagine drifting outward beyond our local neighbourhood of stars. We rise slowly above the disk of the Milky Way. From far away, our galaxy appears like a glowing spiral, its arms wrapped gently around a bright centre. Billions of stars shining together, forming a soft cosmic whirlpool of light. Yet even here, within our own galaxy, there are great stretches of darkness. Between the spiral arms, the number of stars becomes thinner. Clouds of gas drift quietly through space. Dust absorbs faint starlight, creating shadows against the glowing background. And beyond the outer edge of the Milky Way, there is an even greater darkness. Because galaxies themselves are separated by distances almost beyond imagination. The nearest large galaxy to ours, the Andromeda Galaxy, is about 2.5 million light-years away. Light leaving Andromeda began its journey toward us when early human ancestors were just beginning to walk the Earth. By the time that light arrives, entire civilizations may rise and fall. And yet, across those immense distances, the light continues its silent journey. Andromeda itself contains perhaps 1 trillion stars, a vast island of light drifting through space. But even with so many stars shining together, it still appears as only a faint smudge in our night sky, barely visible to the naked eye. The reason is distance. The farther light travels, the more it spreads out. Like ripples moving across the surface of a calm lake, light expands outward as it journeys through space. By the time it reaches us, the brightness has become incredibly faint. And so, although the universe is full of stars, their light becomes diluted across unimaginable distances, leaving much of the sky in darkness. Now let's drift even farther outward, beyond the Milky Way, beyond Andromeda, beyond our small group of nearby galaxies. As we travel across the universe, galaxies appear like scattered lanterns floating in a vast dark ocean. Some glow brightly with new stars being born. Others shine softly with the fading light of older stars. Some collide slowly with their neighbours, merging over millions of years. But between them, there is mostly empty space. Immense cosmic voids, regions where galaxies are rare. These voids can stretch across hundreds of millions of light years. Vast expanses of near darkness, broken only by the faint glow of distant galaxies along their edges. If you could stand within one of these cosmic voids, the night sky would look very different. Instead of thousands of stars, there might be only a handful of faint galaxies visible. The universe would appear almost completely dark. And yet, even in those lonely regions, light would still be passing silently through space. Photons from distant galaxies crossing the void, slowly making their way across the expanding universe. This quiet movement of light, spreading outward across billions of years, is one of the reasons the night sky remains dark. But there is another subtle reason as well. A reason connected to the life cycles of stars themselves. Stars do not shine forever. Every star is born, lives for a time, and eventually fades away. Some stars live for only a few million years. Massive stars burn through their fuel quickly, ending their lives in spectacular explosions called supernovae. Others, like our Sun, live for billions of years, quietly fusing hydrogen into helium, releasing warmth and light into space. But even these steady stars eventually exhaust their fuel. They swell into red giants, shed their outer layers, and slowly fade. Over vast periods of time, stars come and go. Galaxies evolve. New stars form within clouds of gas, while old stars quietly disappear. The universe is constantly changing, and because stars have finite lifetimes, the total light shining in the universe is always shifting. If the universe had existed forever, perhaps the sky would indeed glow brightly in every direction. But our universe is relatively young, about 13.8 billion years old, and that age places a limit on how much light has had time to fill the cosmos. Some stars are simply too far away. Their light has not yet reached us. Others have faded long ago, leaving behind darkness where light once shone. And still others are hidden behind clouds of dust, their glow absorbed before it can travel very far. All of these factors combine, gently shaping the night sky we see today. A sky filled with scattered points of light, surrounded by deep, peaceful darkness. And perhaps that darkness is not something to be puzzled by, but something to appreciate. Because without it, the stars themselves would be much harder to see. The darkness acts like a canvas, allowing the faint lights of distant stars to stand out. If the entire sky glowed brightly, the delicate beauty of the stars might disappear into the glare. Instead, we are given contrast. Light against darkness. Small sparks of brilliance surrounded by quiet space. And that contrast invites us to look upward, to wonder, and to imagine the immense universe beyond our world. When ancient humans first gazed at the stars, they could not have known about galaxies, cosmic expansion, or the age of the universe. But they still felt the mystery of the night sky. Stories were written in the stars. Constellations formed from patterns of light. The darkness between them became the backdrop for myths, legends, and dreams. Even today, with powerful telescopes and advanced science, the night sky still holds that same quiet wonder, because every point of light we see is part of a much larger story. A story written across billions of years. A story of stars forming, shining, and fading. A story of galaxies drifting across the expanding universe. And a story of light travelling enormous distances, finally reaching a small blue planet orbiting an ordinary star. Our star, the Sun. And as we stand beneath the night sky, breathing softly in the cool air, we are part of that story as well. Tiny observers, on a small world, gazing outward into the vast darkness of space. The darkness that once puzzled astronomers, the darkness that inspired great scientific discoveries, and the darkness that quietly reminds us how large the universe truly is. Because when we look up and see the night sky, we are seeing only a small fraction of what exists. Beyond the darkness, beyond the faint stars visible to our eyes, the universe continues. Galaxies beyond galaxies. Light beyond light. Distances so vast that even imagination begins to struggle. And still, the night sky remains calm, silent, dark. A gentle reminder that the universe is both immense and unfinished. Its light still travelling. Its story still unfolding. And somewhere out there, beyond the darkness we see tonight, countless stars are still shining, their light beginning long journeys across the cosmos, slowly making its way through the quiet sea of space, toward a future moment, when someone, somewhere, might look up and see them for the very first time. For a moment, imagine what the sky might look like if the universe were different. Imagine a universe where stars had been shining forever. Not billions of years, but an infinite amount of time. In that kind of universe, every direction you looked would eventually lead your eyes to the surface of a star. The light from those stars would overlap and layer across the sky. Near stars, far stars. Stars beyond galaxies, all sending their light toward you. The result would be overwhelming. The sky would glow constantly. Night would never truly arrive. Even when the sun set, the heavens would remain bright with the combined light of countless distant stars. But that is not the universe we live in. Our universe has an age. And because it has an age, light has had only a limited time to travel. Think of light like travellers spreading outward from their homes. Each star sends out streams of light in every direction, but those travellers can only move so fast. Even at the speed of light, crossing the universe takes enormous amounts of time. And so there are regions of the universe whose light simply hasn't reached us yet. Those regions exist beyond what astronomers call the observable universe. Not because nothing exists there, but because their light has not had enough time to arrive. The observable universe is like a great sphere around us, formed by the distance light has been able to travel since the beginning of cosmic time. Inside that sphere, we can see galaxies, stars, and ancient light. Beyond it, the universe likely continues, but remains hidden from view. And that means the darkness of the night sky is partly a boundary, a quiet edge to what we can currently see. Somewhere beyond that darkness, there may be galaxies shining just as brightly as the ones we observe, but their light is still on its way, still crossing the vast cosmic ocean, still travelling through expanding space, and perhaps it will continue travelling long after our own time on Earth has passed. There is something strangely peaceful about that idea. The universe is not finished revealing itself. The sky we see tonight is only a moment in a much longer story. New light is constantly arriving. Ancient photons that began their journeys billions of years ago continue to reach us. And with each generation of telescopes, scientists detect fainter and more distant sources of light, revealing parts of the cosmos that were once hidden. In a sense, the night sky is slowly brightening. Not because more stars are appearing, but because our ability to see deeper into space is improving. Modern telescopes are sensitive enough to detect incredibly faint signals. Some of the galaxies we observe today are so distant that their light left them when the universe was less than 1 billion years old. Those galaxies are incredibly faint, their light stretched by cosmic expansion, and yet they are still there. Soft whispers of light from the early universe. When astronomers study these ancient galaxies, they're studying the childhood of the cosmos, a time when the first generations of stars were forming, when galaxies were smaller and more chaotic, when the universe itself was only beginning to settle into the structure we see today. And long before those first stars existed, the universe looked very different. In the earliest moments after the beginning of cosmic expansion, the universe was extremely hot and dense. There were no galaxies, no planets, no stars, only a glowing sea of particles and radiation. Light existed everywhere, but it could not travel freely. The universe was too crowded. Photons bounced constantly between charged particles, scattering in every direction. The cosmos was like a thick glowing fog. Then, about 380,000 years after the beginning, something remarkable happened. The universe cooled enough for the first atoms to form. Electrons joined with protons, creating neutral hydrogen, and suddenly, light could travel freely. The fog cleared. Photons began streaming across the universe, uninterrupted for the first time. Those photons are still traveling today. They form the cosmic microwave background, the oldest light we can observe. If we had eyes sensitive to microwave wavelengths, the entire sky would glow softly in every direction. A faint afterglow from the birth of transparency in the universe. But because our eyes see only a small portion of the electromagnetic spectrum, we perceive darkness instead. So the night sky hides far more light than it reveals. There are radio waves crossing the cosmos, infrared light from warm dust clouds, X-rays from violent events near black holes, gamma rays from distant explosions, all of it moving silently through space, invisible to our eyes, but detectable with the right instruments. In fact, some of the most energetic events in the universe remain completely unseen without specialized telescopes. A distant star collapsing into a black hole, two neutron stars colliding, a supermassive black hole feeding on gas at the center of a galaxy. These events release incredible amounts of energy, but much of that energy arrives in wavelengths we cannot see. To human vision, the sky remains calm and dark, but beyond our limited senses, the universe is active and alive with invisible light. Even here within our own galaxy, There are enormous clouds of gas and dust drifting through space. These clouds are the birthplaces of stars. Inside them, gravity slowly pulls material together. Over millions of years, dense clumps form. Temperatures rise, pressure builds, and eventually, nuclear fusion ignites. A new star begins to shine. But when these newborn stars first appear, they're often hidden deep inside thick clouds of dust. Their light cannot easily escape. Visible light is absorbed and scattered by tiny dust grains. From far away, those regions of space appear dark. But if we observe them with infrared telescopes, we suddenly see something extraordinary. Stars being born inside glowing cocoons of gas. Entire clusters of young stars lighting up their surroundings. Once again, the darkness of the sky hides activity that is happening all the time. The universe is constantly creating new light, even in places that appear completely black. And yet, despite all this activity, the night sky still feels peaceful, calm, almost silent. When we stand beneath it, far away from artificial lights, the stars appear steady and gentle. The darkness stretches endlessly between them. It invites quiet reflection. Perhaps that feeling comes from the immense scales involved. The universe moves slowly. Stars evolve over millions or billions of years. Galaxies drift and interact across even longer timescales. Compared to the brief span of a human life, the cosmos changes very gradually. The night sky you see tonight would look almost identical to someone who lived thousands of years ago. Ancient astronomers saw many of the same stars we see now. The same constellations traced across the darkness. The same band of the Milky Way stretching across the sky like a pale river of light. Of course, the universe is still changing. Stars are being born. Others are dying. Galaxies are colliding slowly in the distance. But these changes unfold across such enormous spans of time that the sky appears almost timeless. And perhaps that timelessness is part of why the darkness feels comforting. The universe is vast, but it is also patient. Light travels slowly across its great distances. Stars shine steadily for billions of years. Galaxies turn slowly through space like giant cosmic wheels. And in the quiet darkness between the stars, the universe waits. Waiting for new light to emerge. Waiting for distant photons to complete their journeys. Waiting for curious minds to look upward and wonder. Somewhere tonight, on countless worlds orbiting distant stars, other observers may also be looking into their own night skies. They may see different constellations, different galaxies, different arrangements of light and darkness. But they might ask the same question. Why is the night sky dark? And somewhere, perhaps billions of light years away, another mind might slowly discover the same beautiful answer, that the darkness is not a flaw in the universe. It is a clue, a quiet hint that the cosmos has a beginning, that light has a finite age, that space is expanding, and that the story of the universe is still unfolding. The darkness of the night sky is not emptiness. It is the space where future light is still traveling. Photons crossing unimaginable distances, slowly making their way across the expanding universe. Some of them began their journeys long before our planet existed. Some are just beginning. And far into the future, long after today's stars have faded, new stars will still ignite in distant galaxies. New light will still spread outward across space. And somewhere, perhaps in a future civilization, someone may once again stand beneath a quiet sky, look up into the darkness, and feel the same sense of wonder that humans have felt for thousands of years. A quiet curiosity about the universe, a peaceful awareness of how vast it truly is, and a gentle realization that the darkness above us is not empty at all. It is simply the quiet space between the lights. In a universe that is still learning how to shine, there is another gentle way to think about the darkness above us. Imagine the universe as an enormous ocean. Not an ocean of water, but an ocean of time and distance. Stars are like distant lighthouses scattered across that ocean, each one shining its light outward in all directions. but the ocean is so vast that most of the light spreads out, growing fainter and fainter as it travels. Only a very small portion of that light ever reaches any particular place. And so when we stand on our small world, looking upward, we see only the nearest or brightest of those distant lights. The rest fade quietly into the darkness. This is why the night sky feels spacious, why there is so much calm emptiness between the stars. The universe simply spreads things very far apart. Even inside galaxies, stars are separated by enormous distances. If our sun was shrunk down to the size of a small coin, the nearest star would still be hundreds of kilometers away. Between those stars lies mostly empty space. Cold, quiet, and incredibly vast. Light passes through these regions almost without interruption. Photons move silently between the stars, crossing distances that take years, centuries, or even millions of years to travel. But while space is mostly empty, it is not completely empty. Floating through the darkness are tiny particles of dust, atoms of hydrogen drifting slowly through the galaxy, faint magnetic fields stretching across space, occasional clouds of gas so thin that even the best vacuum on Earth would seem dense by comparison. These delicate ingredients, scattered across the universe, slowly gather over time. Gravity gently pulls them together. Gas collects into larger clouds. Clouds collapse inward, and eventually, new stars are born. So the darkness between the stars is not just empty space. It is also the birthplace of future light. Hidden within those dark clouds, new stars are slowly forming. Their glow still buried deep within thick layers of gas and dust. Given enough time, those stars will emerge. They will ignite with steady nuclear fire, and they too will begin sending their light across the cosmos. In that sense, the darkness of the universe is temporary, a quiet pause before new light appears. When we look up at the night sky, we are seeing a mixture of past, present, and future. Some of the stars we see tonight may already be gone. Their light left long ago, continuing its journey toward Earth even after the stars themselves faded. Other stars we see are still shining steadily, continuing to send fresh light across space. And somewhere beyond our view, new stars are still forming, their light not yet visible to us. The sky is like a great timeline written in starlight. Each point of light tells a story from a different moment in cosmic history. Some stories began a few years ago. Others began millions or billions of years in the past. And the darkness between those lights is simply the space where those stories have not yet reached us. When astronomers study the sky, they're essentially reading that timeline. Powerful telescopes allow them to see deeper into space, and therefore further back in time. Each improvement in technology reveals more distant galaxies, more ancient light, more clues about how the universe began and how it has changed. But even with the most powerful instruments ever built, there is still a limit to what we can see, a horizon beyond which light has not yet arrived. Beyond that horizon, the universe may continue almost endlessly. More galaxies, more stars, more darkness, and perhaps more worlds like our own. Planets orbiting distant suns, drifting quietly through space. Some of those worlds may have their own night skies, their own observers looking upward into the darkness. On those distant planets, the sky might look very different. If they orbit a star within a dense star cluster, their night sky might glow with thousands of brilliant stars. If they live in a quiet region of a galaxy, they might see only a few faint lights scattered across the darkness. But no matter where they are, the same cosmic rules apply. Light takes time to travel. Stars have finite lifetimes. Space continues to expand. And so the sky will always contain both light and darkness, a balance between the two. The darkness reminds us that the universe has limits in time. The light reminds us that those limits are slowly expanding, because every second light from distant places continues to arrive. Every moment the observable universe grows slightly larger. New photons cross the boundary of what we can see. New pieces of the cosmic story become visible. And somewhere in the depths of space, stars are continuing to ignite. Future light beginning its long journey. It is easy to forget how extraordinary this is. For most of human history, people believed the stars were fixed lights placed on a celestial sphere, permanent, unchanging. But modern astronomy has revealed something far more beautiful. The universe is alive with motion and change. Stars are born. Stars evolve. Stars die. Galaxies drift through space like enormous islands of light. And all of it unfolds slowly across billions of years. Yet from our perspective on Earth, the sky still appears calm, still, almost eternal. That calmness can make the universe feel peaceful. When we look up at the stars, we are seeing a universe that moves slowly enough for us to simply observe and wonder. The darkness gives our eyes space to rest. The scattered lights give our minds something to explore. Perhaps that is why humans have always been drawn to the night sky. Long before telescopes, long before science, people gathered under the stars. They watched the constellations rise and fall through the seasons. They noticed patterns in the movement of planets. They wondered about the light shining in the distance. Even today, with all our knowledge about galaxies and cosmic expansion, the night sky still inspires that same quiet curiosity. Because when we stand beneath it, we are reminded of something simple and profound. We are part of a very large universe. A universe filled with light that has travelled incredible distances. A universe where darkness and brightness exist together, and where the story of cosmic light is still unfolding. So the next time you look up at the night sky, and notice how dark it is, you might remember that the darkness itself is meaningful. It tells us that the universe has a beginning. It tells us that light takes time to travel. It tells us that space is expanding, carrying galaxies further apart. And it tells us that there are still regions of the cosmos whose light has not yet arrived. The darkness is not emptiness. It is patience. The universe waiting for its light to reach us. Somewhere out there, photons are travelling right now, crossing billions of light years, moving through silent space. Perhaps one of them began its journey when the first galaxies formed. Perhaps it has been travelling for nearly the entire age of the universe. And one night, long in the future, that photon might finally arrive. It may fall gently onto the mirror of a telescope, or pass quietly through an atmosphere, or reach the eyes of someone standing beneath the stars. In that moment, a journey across cosmic time will come to an end. A message from the distant universe will finally be received, and the darkness of the sky will reveal just a little more light. Because the universe is always sending its light outward, across space, across time, through the quiet darkness between the stars. And somewhere in that vast ocean of night, new light is already on its way. If you were able to travel far away from Earth, far beyond our solar system, the night sky would slowly begin to change. At first, the constellations would look almost the same. The familiar shapes people have recognized for thousands of years would still appear in the sky. Orion would still raise his bright shoulder of stars. The Big Dipper would still stretch its gentle curve across the darkness. But as you moved farther through space, those patterns would begin to shift. The stars that appear close together from Earth are often separated by enormous distances. They only seem grouped because of the angle from which we see them. From another location in the galaxy, the constellations would dissolve into completely new arrangements. Stars would move apart and new stars would appear where darkness once was. Old patterns would disappear. The sky would become unfamiliar. This is another quiet reminder that the night sky is not a fixed painting above us. It is a three-dimensional universe. Stars are scattered across vast depths of space, and we see them projected onto the sky like distant lights on a curved dome. But in reality, each star occupies its own place in the galaxy, moving slowly through space. Over thousands of years, these motions begin to change the appearance of the constellations. Ancient astronomers saw slightly different skies than we do today. And far in the future, the constellations we recognize now will no longer exist. Stars drift. Galaxies rotate. The universe is slowly reshaping the sky. Yet these changes are so gradual that to us, the stars seem almost perfectly still. Night after night, they return to nearly the same positions. Their quiet steadiness has guided travelers across deserts and oceans. It has helped humans measure the passing of seasons, and it has inspired countless stories across cultures and civilizations. But if we could wait long enough, millions of years, the sky would eventually transform. Some stars would move closer to us, growing brighter. Others would drift farther away, fading slowly into darkness. A few nearby stars might even explode as supernovae, briefly becoming brighter than entire galaxies. For a short time, the night sky would blaze with brilliant new light. Then, gradually, that light would fade again. The universe is always shifting between brightness and darkness. Even the Milky Way itself is slowly changing. Our galaxy is a vast spiral of stars turning gently through space. It takes our Sun about 230 million years to complete one orbit around the galactic center. That means since the dinosaurs disappeared, our solar system has only traveled a small fraction of its journey around the galaxy. Over time, the positions of stars around us slowly change as we move through the Milky Way. The sky our distant ancestors saw millions of years ago looks different from the one we see now. And the sky that future beings will see millions of years from today will be different again. But there is an even greater change waiting far ahead in cosmic time, far beyond human history, far beyond the lifespan of our Sun. In several billion years, something remarkable will happen in our corner of the universe. Our galaxy, the Milky Way, will slowly approach another enormous galaxy nearby, the Andromeda Galaxy. Right now, Andromeda appears as a faint misty patch in the night sky, barely visible without a telescope. But it is actually a massive spiral galaxy even larger than our own, containing perhaps 1 trillion stars, and it is slowly drifting toward us. The two galaxies are moving closer together at about 100 kilometers per second. It will take billions of years, but eventually they will begin to interact. The outer regions will stretch and twist as gravity pulls them together. Long streams of stars will arc through space. New waves of star formation will ignite as gas clouds collide. For a time, the night sky of Earth, or whatever world exists then, will become far more dramatic. The Andromeda Galaxy will grow larger and brighter in the sky. Eventually it will stretch across huge portions of the heavens, filling the darkness with swirling bands of starlight. After many slow passes through each other, the two galaxies will merge. Their stars will settle into a new, larger galaxy. A single giant system formed from the union of both. But even during that spectacular event, the sky will still contain darkness. Because even when galaxies collide, the distances between stars are so enormous that direct collisions between stars are extremely rare. Most stars will pass by each other quietly, separated by light years of space. The night sky will change, but it will never become completely bright. The universe will always contain more darkness than light, and that balance will continue far into the future. In fact, if we travel far enough forward in time, trillions of years into the future, the universe may grow darker than it is today. Stars will slowly use up their nuclear fuel. Many galaxies will stop forming new stars. The brightest stars will disappear first, leaving behind smaller and dimmer ones. Over unimaginable spans of time, the universe may gradually fade. A future sky might contain far fewer bright stars. Galaxies will drift farther apart as cosmic expansion continues. Eventually, distant galaxies may move so far away that their light can no longer reach us at all. From within one isolated galaxy, observers might see a much darker universe than we see today. They might not even realize that other galaxies ever existed. Their observable universe could contain only their own island of stars. The vast cosmic web we see today would be hidden beyond the reach of light. But even then, darkness would still not mean emptiness. There would still be faint light from long-lived stars. There would still be radiation drifting through space. There would still be quiet cosmic processes unfolding over enormous stretches of time. The universe changes, but it rarely becomes completely silent or completely dark. Light always finds a way to travel. Stars continue to form for billions of years, and even when stars fade, their remnants continue to shape the cosmos. White dwarfs slowly cooling, neutron stars spinning in darkness, black holes quietly pulling in matter and releasing bursts of energy. These objects remind us that the universe never truly stops evolving. The darkness between stars is simply the stage on which these events occur. When we stand beneath the night sky today, we are witnessing one chapter of a very long cosmic story. A chapter filled with bright stars, glowing galaxies, and vast quiet spaces between them. The darkness we see is part of that balance. Without it, the universe would feel crowded and overwhelming. With it, the stars can shine clearly. Their light becomes more meaningful against the calm background of space. Perhaps that is why the night sky feels so peaceful. It is not completely bright, and it is not completely dark. It is a gentle mixture of both. Tiny points of light scattered across immense darkness. Each one carrying a story from somewhere far away. Each one sending us a message from another place in the universe. And between those lights lies the quiet canvas of space. A vast, silent expanse where future light is still travelling, where new stars are slowly forming, and where the story of the cosmos continues to unfold, one photon at a time. If you stay outside long enough on a very clear night, something interesting begins to happen. Your eyes slowly adjust to the darkness. At first you might only notice the brightest stars, a few familiar constellations, maybe a faint band of the Milky Way stretching across the sky. But as minutes pass, your vision becomes more sensitive. Fainter stars begin to appear. Small clusters of light emerge where you first saw only darkness. The Milky Way itself becomes brighter and more detailed, revealing a hazy river of countless distant stars. What felt like an empty sky slowly fills with light. This quiet transformation is a reminder that the universe often hides its details in subtle ways. Sometimes the darkness is not truly empty. Sometimes our eyes simply need time to notice what was already there. The Milky Way is a perfect example. From cities filled with artificial lights, it is almost invisible. The sky appears nearly blank. Only a few of the brightest stars manage to shine through the glow of streetlights and buildings. But far away from those lights, in quiet deserts, mountains, or open plains, the Milky Way suddenly reveals itself. A wide glowing band stretches across the sky. Soft clouds of starlight ripple through the darkness. Those clouds contain billions of distant stars, too faint and too numerous for our eyes to distinguish individually. Their combined light forms the pale glow we see. And yet, even that glowing band contains dark regions. Dark lanes that cut across the Milky Way like shadows. For a long time, astronomers wondered what these dark areas were. At first, they thought those regions might be empty spaces where stars simply did not exist. But later observations revealed something more interesting. Those dark patches are actually enormous clouds of dust drifting through the galaxy. The dust blocks starlight from behind it, creating silhouettes against the brighter background of the Milky Way. In other words, the darkness we see there is not emptiness. It is a shadow. Behind those shadows, countless stars are still shining. Their light simply cannot reach us. This idea appears again and again when we study the universe. Darkness often hides something deeper. Sometimes it hides stars behind clouds of dust. Sometimes it hides galaxies so distant their light has faded. Sometimes it hides wavelengths of light our eyes cannot detect. The universe is full of light we cannot see. If human eyes could detect radio waves, the sky would look very different. Powerful radio signals from galaxies and nebulae would glow across the heavens. If we could see infrared light, warm clouds of gas and dust would shine brightly where the visible sky appears dark. If we could see X-rays, the regions around black holes and neutron stars would flash with intense energy. In every direction, the universe is glowing. Our eyes simply capture a very small portion of it. It is like listening to a vast orchestra but hearing only a few instruments. The full symphony is still playing, even if we cannot hear all of it. That hidden light is one of the reasons astronomers build telescopes that observe different wavelengths. Some telescopes study radio waves, others observe infrared light. Some look for ultraviolet radiation or powerful bursts of gamma rays. Each new window reveals parts of the universe that were previously invisible. Regions that once appeared dark suddenly become filled with structure and activity. Entire galaxies appear where nothing seemed to exist before. And sometimes, the darkest places in the sky turn out to be the most fascinating. Black holes are one example. A black hole itself emits no visible light. Its gravity is so strong that even light cannot escape once it crosses a certain boundary. To our eyes, a black hole would appear completely black, an empty circle against the background of stars. But the regions around black holes can glow intensely. Gas falling toward a black hole heats up dramatically. Temperatures rise to millions of degrees. Powerful radiation bursts outward as the gas spirals inward. Some of the brightest objects in the universe, quasars, are powered by enormous black holes at the centers of distant galaxies. These objects can shine brighter than entire galaxies. Yet the black hole itself remains invisible, hidden in darkness at the center of all that light. This contrast between light and darkness appears everywhere in the cosmos. Bright stars forming within dark nebulae. Brilliant galaxies surrounded by vast empty space. Explosions of energy unfolding within the quiet darkness between the stars. The universe seems to rely on this balance. Light revealing structure. Darkness giving that structure room to exist. Without darkness, the light would blend together endlessly. Without light, the darkness would tell us nothing about what lies beyond. Together they create the sky we see every night. A sky filled with quiet beauty. A sky that has inspired curiosity for as long as humans have looked upward. Long before modern astronomy, people noticed how dark the sky was. They noticed how the stars seemed scattered across it like tiny sparks. And they began asking questions. What are the stars? How far away are they? Why is the sky dark at night? For centuries, these questions remained mysteries. But slowly, through careful observation and patient thinking, humans began to uncover the answers. They discovered that stars are distant suns. The galaxies are vast collections of billions of stars. That the universe itself has been expanding for billions of years, and that the darkness of the night sky is actually a clue about the nature of the cosmos. It tells us that the universe has not existed forever in its current form. It tells us that light has a finite speed. It tells us that distant regions of space are still beyond our view. What once seemed like a simple observation, a dark sky above our heads, turned out to reveal profound truths about the universe. Sometimes the most ordinary experiences hide the deepest mysteries. A quiet walk under the stars, a moment spent looking upward, a simple question about the darkness between the lights. These small moments connect us to something enormous, because the night sky is not just scenery, it is the visible edge of the universe itself. A window into distances so vast that light needs billions of years to cross them, and yet that distant light eventually arrives, here, on a small planet orbiting a single star in a quiet corner of a galaxy. It reaches the eyes of curious observers who wonder about its origin, who try to understand what the darkness means, and who slowly piece together the story of the cosmos. The story continues to grow with every generation. New telescopes are being built right now. Some will orbit Earth. Others will sit high on remote mountaintops. A few may one day be placed on the far side of the moon, where radio signals from Earth cannot interfere. These instruments will peer deeper into space than ever before. They will detect fainter galaxies. They will study the first stars that ever formed. They may even reveal new mysteries about the nature of space and time. And with each discovery, the darkness of the sky may reveal a little more of its hidden light. But no matter how much we learn, the night sky will probably always remain partly dark, because the universe is vast beyond imagination. Even with the most powerful telescopes, there will always be regions too distant to see. There will always be light that has not yet arrived. There will always be places where darkness quietly fills the space between distant stars. And perhaps that is part of what makes the night sky so beautiful. It reminds us that the universe is larger than our understanding, that there are still mysteries waiting far beyond the stars we can see, that somewhere out there, in the deep quiet of space, light is still travelling toward us, crossing billions of light years, passing through darkness that seems endless, moving patiently through the expanding cosmos. One day, some of that light will finally arrive, and when it does, the darkness of the night sky will reveal something new. Another star, another galaxy, another small piece of the story of the universe. There is something quietly humbling about realizing how much darkness surrounds the light we see. When we look up at the stars, it can feel as though the sky is full of them. On a clear night, thousands of tiny points sparkle above us, and the Milky Way stretches like a soft river of light across the heavens. But even that beautiful sight is only a small glimpse of the universe. If you could leave Earth and travel far above our galaxy, you would see the Milky Way as a wide spiral of glowing stars drifting through space. Its arms would shine with the combined light of billions of suns. Yet beyond that glowing island, there would be immense darkness. Another galaxy might appear in the distance, a faint swirl of light separated by millions of light years of empty space. Then another, and another. Between them would stretch enormous regions where almost nothing shines at all. The universe is not filled with light everywhere. Instead, light gathers into islands, stars inside galaxies, galaxies inside clusters, while the vast majority of space remains dark and quiet. This structure is sometimes called the cosmic web. On the larger scales, galaxies are arranged along enormous filaments that stretch across the universe like glowing threads. Where these threads intersect, giant clusters of galaxies form. Hundreds or even thousands of galaxies drift together in those regions, bound by gravity. But between those filaments lie cosmic voids. These voids are some of the largest structures in the universe. They can span hundreds of millions of light years, containing very few galaxies at all. If you were somehow able to float inside one of these voids, the night sky would look incredibly empty. Only a handful of faint galaxies might be visible, scattered across an immense black sky. The darkness there would feel almost complete. And yet, even in those enormous voids, light would still be travelling. Photons from distant galaxies would be crossing the void slowly, taking millions of years to pass from one side to the other. The universe is always in motion, even when it appears silent and still. Light moves constantly. Space expands gradually. Galaxies drift slowly along the great cosmic web. This quiet movement is happening everywhere, all the time. But because the distances are so vast, everything unfolds at a pace that feels almost timeless. That is part of what makes the darkness of the night sky feel so peaceful. It reflects a universe that moves slowly and patiently. Stars burn steadily for billions of years. Galaxies rotate over hundreds of millions of years. Even the expansion of the universe happens gently, stretching space little by little across immense spans of time. Against this backdrop of slow cosmic change, the night sky becomes a place of calm, a quiet reminder of how vast the universe truly is. For humans, our lives unfold quickly compared to these cosmic timescales. Civilizations rise and fall in only thousands of years. Technologies change within decades. Entire generations come and go in the blink of an astronomical eye. Yet above us the stars continue shining. The same constellations seen by ancient observers still appear in our skies today. The light reaching us from distant galaxies began its journey long before humans ever existed. When you think about it that way, the night sky becomes a bridge between past and present. Some of the photons entering your eyes tonight began travelling before the first animals walked on land. Others left their stars while early humans were learning to use tools. Still others began their journeys before our solar system even formed. Every beam of starlight carries a tiny piece of history, and the darkness between those beams is simply the space where that history has not yet reached us. When astronomers look deeper into the universe, they're essentially travelling backward through time. The farther away they look, the earlier the universe appears. With powerful telescopes, scientists have detected galaxies whose light has been travelling for more than 13 billion years. These galaxies formed when the universe was very young. Studying them allows astronomers to understand how the first stars were born. But even with these observations, there is still a limit. Beyond a certain distance, the universe becomes too young for stars to exist. Beyond that point lies a time before galaxies formed. And beyond that, a time before atoms existed at all. The darkness of the night sky is partly the result of that cosmic history. Stars did not exist at the beginning. They had to form slowly over time. In the early universe, there were no shining suns lighting up the darkness. Only hot gas and faint radiation-filled space. Eventually, gravity gathered that gas into dense clouds. Inside those clouds, the first stars ignited. These early stars were likely enormous and short-lived, burning brightly before exploding as powerful supernovae. Their explosions scattered heavy elements into space, elements that would later become part of planets, oceans, and even living beings. In a very real sense, the atoms inside our bodies were forged inside ancient stars. The universe slowly built complexity from those stellar remnants. New generations of stars formed. Galaxies grew larger. Planetary systems appeared around young stars. And on at least one small world, life eventually emerged. So when we look up at the night sky and see its darkness, we're also looking at the environment that allowed this cosmic story to unfold. Without vast spaces between stars, galaxies would collide constantly. Without darkness between regions of light, structures in the universe might never have formed. The quiet emptiness of space allowed gravity to shape matter into stars and galaxies. It allowed light to travel enormous distances. It allowed cosmic evolution to proceed slowly across billions of years. The darkness of the night sky is part of that balance. It gives the universe room to grow, room for galaxies to drift, room for stars to form, room for light to journey across unimaginable distances. And it gives us something else as well, a place for wonder. Standing beneath the stars has always inspired curiosity. It invites questions about our place in the universe. It encourages us to imagine distant worlds and unseen galaxies. It reminds us that our planet is just one small point in an enormous cosmic landscape. Yet that realization can feel comforting rather than overwhelming, because it means the universe is larger than our daily worries, larger than our problems, larger even than our understanding. When we look into the dark sky, we're seeing the vastness that surrounds us. But we're also seeing the light that has managed to reach us across that vastness. Tiny sparks of brightness scattered across the darkness, each one telling us that somewhere far away a star is shining. And somewhere even farther away, light is still on its way, travelling patiently through the quiet cosmos, crossing billions of kilometres of empty space, moving steadily through the expanding universe, until one night, long after its journey began, it finally arrives, and becomes a new point of light in someone's sky. And as the night grows quieter, and the stars continue their slow journey across the sky, it's comforting to remember that the darkness above us is not truly empty. It is simply the vast space where light is still travelling. Some of that light began its journey billions of years ago, long before our planet existed, long before the first life appeared on Earth. And tonight, after crossing unimaginable distances, a tiny fraction of that ancient light finally reaches us. It touches our atmosphere, slips quietly through the air, and for a brief moment, it reaches our eyes. A journey across the universe, ending in a single moment of sight. When you look up at the night sky, you're not just seeing stars, you're seeing history, messages carried by light from distant corners of the cosmos. Some stars you see may already be gone, their final light still travelling through space. Some galaxies are so far away that their light began moving toward us when the universe itself was still young. And beyond the darkness you see tonight, countless more stars are still shining. Their light is already on its way, moving silently through the deep quiet of space. Perhaps one day, far in the future, that light will reach another world, another observer, another curious mind looking up into the sky, and they might wonder the same thing we once wondered. Why is the night sky dark? Until then, the universe continues its quiet rhythm. Stars burning slowly, galaxies drifting across the expanding cosmos, and light patiently travelling through the darkness between them. So tonight, if you ever find yourself beneath a clear sky, far away from city lights, take a moment to look up. Let your eyes adjust to the darkness. Watch as more and more stars slowly appear. And remember that every point of light you see is part of a story billions of years in the making. a story still unfolding across the universe. If you enjoyed this quiet journey through the cosmos, consider subscribing to the channel. There are many more calm explorations waiting ahead, gentle stories about space, science, and the mysteries of the universe, designed to help your mind slow down and drift peacefully into rest. And if you'd like to continue traveling through the universe tonight, you might enjoy another video from the Sleepy Scientist. Until then, thank you for spending this quiet moment among the stars. And wherever you are in the world, may your night be calm, peaceful, and full of wonder.